In this video, we're going to take a look at transformations with rational functions. And as you can see here, they give you a function, let f of x equal 2 over x. And with each of these problems, we would just want to describe the transformation of the graph. So it says g of x equals 2 over x plus 3. So as you can see, this piece is exactly the same, the 2 over x. The only thing that's different is this plus 3 on the end. So think about, what would you do to f of x? What would you do to f of x to have a plus 3 on the end like that? Well, all you'd want to do is take your function and add 3 to it. So if I take f of x, that function, and I add 3 to it, that's going to give me 2 over x. That's this f of x part plus the 3. And that matches up perfectly with g of x. So I know that g of x is just equal to my original function plus 3. And if you remember your transformation of functions information, whenever you add 3 on the outside like this, that is a vertical shift 3 units upward. So we have a vertical shift, and we're moving up 3 units. Let's take a look at the second problem. Now we have g of x equals 2 over x minus 3. So now the difference is that what once was an x down here in the denominator is now become an x minus 3. So what would I do to f of x to change this x to an x minus 3? And focus on that idea. This is how I got the x down here. It's my input, right? So f of my input is equal to really 2 over my input. So how am I going to get x minus 3 down here? Well, I'm going to change the input. So notice I can't just add 3 on the outside or subtract 3 on the outside. That would give me 2 over x minus 3. But I want the x minus 3 to be down here in the denominator. So all I need to do is evaluate my function, f of x. Whoops. I want to evaluate it at x minus 3. I just lost a lot of my notations there. So do f of x minus 3, and that will equal 2 over x minus 3, which is g of x. So g of x is equal to f of x minus 3. And once again, if you think of your transformations, anytime I have something on the inside of the grouping symbol here, when it's f of x minus 3, that's a horizontal shift. And remember, horizontal shifts are a little bit tricky. You see this minus sign, you might want to automatically think it's to the left, but it's actually to the right. So this is a horizontal shift 3 units to the right. All right, I have 2 more examples I want to take a look at. Next one is g of x equals negative 2 over x, and I copied my original function down here. F of x is equal to 2 over x. So how am I going to get this negative here? What do I do to f of x to get a negative in the front like that? Well, one thing I can do is just make this negative f of x. Negative f of x would be negative 2 over x, which is the same thing as having negative 2 over x written in that way. And that's your g of x function. So in this case, with the negative sign in front of f of x, you need to be thinking reflection. And if it's a negative in front of f of x, that is a reflection over the x-axis. Last example. So now we have g of x equals 1 over x plus 2. So this one here is a little more challenging just because you have 2 things to deal with. So let's deal with this in baby steps. Just like a previous problem, the way that we changed this denominator here is we just changed how we evaluated the original function f. And if we evaluate the function f at x plus 2, that will give us 2 over x plus 2. So all I did was I took my original function f of x, which is 2 over x. If I evaluated x plus 2, it's going to change this denominator. So this changed to this. Now, obviously, I'm not done. I want this top piece to be a 1. So how can I change this 2 to a 1? What can I do to this left-hand side? Well, one thing I can do is I can multiply this entire function by 1/2. By multiplying by 1/2, this will change this to 1/2 times 2 over x plus 2. These 2's will cancel out. And look at that. I have 1 over x plus 2. So these two changes, evaluating the function at x plus 2, that's going to be a horizontal shift 2 units to the left. And multiplying by 1/2 out front like that is a vertical shrink. So a vertical shrink, because you're multiplying the original function by 1/2, and a horizontal shift 2 units to the left.